Okay, good evening all. I think you can hear me now. Okay. Okay, start now. Now 45. Okay. Okay. Now today we are going to start our very important topic, that is kinetic chemistry. Recording. Sorry. Okay, kinetic chemistry. After we'll try to complete this lesson within this month. Within this, I think this month also we have 4 days. Yeah, within these 4 days we try to complete. This lesson is very short lesson, not long lesson. After this lesson, that is kinetic chemistry. Kinetic chemistry. Okay, after this lesson, I hope to complete your very long 3 lessons we have in chemistry. They are cell structures. Cell structure is a very long lesson. There are, I think, more than 10 parts. In here, we have to discuss about cell types, tissue types, microorganisms, productions, and that's a very long lesson. The cell structure, and that's a biology lesson. The cell structure is a biology lesson. We have only 2 biology lessons. No, other one is we completed the biomolecule. We completed this cell structure, cell structures. Cell structures, and what other one is the environmental chemistry. And what other? Industrial chemistry. We have another one, natural products. Natural products. Okay, they all 4 lessons are very long lessons. There is no any calculation. Full theory lessons. All these 4 lessons. That's a biology lesson. All these 3 lessons are chemistry lessons. They are chemistry. That's a biology lesson. They are very long, but no any calculation. Therefore, I hope to print these all books. Books mean tuned, and send you, post you into courier or whatever. I will inform you how to send that. Okay, all these 4 lessons tute pack I will prepare, then I will inform, then you can send me the your address, then I will send that. These 4 lessons, normally we not going to write any note of this lesson. They are very long lesson, therefore we can complete this lesson after you receive the tute. Then we can discuss every concept. That means the in cell structure, microorganism production part is, I think, the cell structure lesson like a book, that is very long lesson. The environmental chemistry same, natural products also. Industrial chemistry not too long, but it something. Yeah, we have in industrial chemistry, we need to discuss about soap production, biodiesel production, caustic soda production, what other, paper production, and paper production, phosphate fertilizer production, and yeah, that's all. Yeah, one is missing. Soap production, biodiesel production, paper production, caustic soda production. Yeah, only five. Apatite, that means phosphate fertilizer production. Okay, we can discuss this lesson after you review. Mute your mic. Okay. Okay. Now we can start. Okay, that's the kinetic chemistry. It's not long lesson, but there is some calculation part. That's the special. I told you in any these theory lessons don't have any calculation part. Theory lessons don't have that. Mean all theory, that microbial production, vinegar production, yogurt production, other all productions are only theory, no any calculation. But in this lesson, the kinetic chemistry lesson, we have special calculation part. Okay, start now. Aishat, you came now. We discussed about our future plan, how to complete our lessons within this period. Okay. Okay. Now, sorry, kinetic chemistry. I guess our new topic. Today topic is kinetic chemistry. This kinetic word, you remember we used in our heat lesson. I think you remember the molecule. I think kinetic word. Do you remember where we use the kinetic word? Kinetic. Kinetic word we used in where? In heat lesson? Remember? Kinetic. Do you remember? This kinetic word? Kinetic. Kinetic word. Kinetic mean what? Before moving to lesson, this lesson is very interesting. Okay, very interesting part we discussed in this lesson. Therefore, continuous come and complete all works. Otherwise, final calculations anyone you can't do. You can't anyone understand if you not understood one by one part. Okay, the continuity is very important in this lesson. Other lessons like theory lessons you can read and you can understand, but this lesson is you can't. Okay, what is a kinetic? What is a kinetic mean? And do you remember where we meet the kinetic word in heat lesson? Kinetic. Kinetic mean what? Okay, don't need heat lesson. What is a kinetic mean what? Kinetic. Yeah, moving. Yeah, that's something idea. Yeah, there is kinetic mean motion. Yeah, yeah. Other kinetics mean related to motion or movement, whether in physics. Kinetic energy. Yeah, chemistry. Very good, very good. Yeah, that's the meaning of kinetic. Okay. In this kinetic, I think, yeah, heat lesson. Do you remember we discussed in kinetic the molecules when we discussing about heat expansion? The molecules are when increase the temperature of some object. I told you molecule kinetic energy is increasing. Actually, that's the thing. Actually, in this lesson, we discussing about this molecule kinetic energy. Molecule kinetic energy. This lesson we mainly discussed about the rate of reaction. Okay, rate of reaction is our target. Rate of reaction is the target of this lesson. Rate. The rate increase mean, the rate mean what? The rate mean like speed. Okay, the rate mean like speed. The in this lesson we mainly discussed about the rate of chemical reaction. Rate of chemical reaction. Okay, one by one we discussed rate of chemical reaction. That is our ultimate target of this lesson. Chemical reaction. That is our ultimate target. Our main target is calculate the rate of chemical reaction. Rate. That means the rate of chemical reaction mean that is very related to the rate of chemical reaction. Well, related to this molecule. Molecule mean what? Molecule. Molecule we discuss biomolecule part also. You know, in heat lesson also I explained this part. Every matters. Normally there are what alarm? Yeah, what is alarm message? I can't understand. No, no, not related to heat lesson, but the kinetic energy we discussed in heat lesson. That's this lesson is not related to heat lesson. Now, okay, heat lesson also. This part we discussed the matter types of matters of types of matters. I told you mainly three types of matters in the world: solid, liquid, and gas. Solid, liquid, and gas are the main types of matters. Okay, I told you when we the solids, when we consider about solid, they are molecules or atoms are very uh, bond each other, very tough bonds, very strong bonds, very strong bond. They are intermolecule bonds are very strong. Intermolecule bonds are very strong. Solids are produced by molecule. Then liquid also produced by molecules. They are intermolecule bond, not much strong than, it is less strong than solids. It's strong, but not than solids. Okay. Then gases are very molecules are very freely moving. They are very weak intermolecule bonds. Intermolecule bond means the bond between this molecule. Okay, the bond between these molecules, they are very, very strong. Normal, general strong, that is very weak. The intermolecule bond. What happened to intermolecule space? Intermolecule space very low. That also the intermolecule space higher than solids and lower than gas. That's normal. Very intermolecule space is very higher in gases. Intermolecule spaces is very high. Okay, now you can see every matters. They are the main types of matters in our world. Every matters are produced by molecules. You know, everything are produced by everything in our world. Everything. Okay, like same us, even us. We discussed in biomolecule part. Our every parts, our organs, our everything are produced by molecules. No carbon, hydrogen, oxygen. They are the molecules. Samely, everything in our world produced by molecule like this. It depends on the physical state. If it is solid, they are very strong bond and intermolecule space are very low. That's a liquid. Gas, when you consider gas, that is intermolecule space very high and very weak intermolecule bonds. Okay. Now you can see everything in our world produced by molecule. Now now we are not going to discuss everything in our world. Everything in world we discussed in heat lesson. We discussed everything. When increase the temperature, the size is increasing. That's a heat expansion. But in this lesson, we are going to discuss about chemical reaction. What is the meaning of this chemical reaction? Do you have idea what is a, how we define, how we explain what is the meaning of chemical reaction? Chemical reaction. Chemical reaction. Chemical reaction. Do you have idea how we define chemical reaction? Chemical reaction. Adish, I think you know, you already done this lesson. Chemical reaction mean this chemical reaction. Yeah, before we discuss the rate of chemical reaction, what is a chemical reaction? Very good. Yeah, yeah, lot of answer. Very good. Reaction between chemical substance with, yeah, in thermal chemistry also we discussed about some part of chemical reaction. Yeah. Yeah, yeah, the chemical reaction mean, yeah, all answers are correct, but the full answer, the chemical reaction mean some substance mean reactant. They be called as reactant after chemical conversion. After chemical conversion, that word is should there. That's compulsory. The some substance, they are reactants after some chemical conversion that convert into product. After some chemical products, that is the meaning of chemical reaction. After some the chemical conversion, otherwise it's not a chemical reaction. The physically also, the when we consider about ice ice cube ice ice cube, if we heat that, it's converted into its, but is it chemical reaction? No, it's a physical state change only. But if any substance convert into another substance, convert into different substance, that otherwise reactant, that means initial substance convert into different substance, that's a product, okay, by a chemical conversion. That's the meaning of by a chemical conversion. Chemical conversion. Chemical conversion. That's the meaning of chemical reaction. Some substance convert into products, another different form of substance, that means product, by a chemical conversion. That's the meaning of reaction. Okay, chemical reaction, not reaction, chemical reaction. That's the meaning of chemical reaction. Okay, that's the base of this lesson. Now you can see we discuss in different areas. No, now we have to combine them. Otherwise, I think you confused now. Okay, I will explain how to combine these each theories one by one. Okay, in this lesson, the tute I sent to group, but in this lesson is very short lesson. Therefore, I can give you a full note. We write down. Okay, take your books and write down kinetic chemistry. The tute also a lot of spaces. Therefore, we have to complete. Okay, no need. We will come. We'll write down full note. I forgot today. Yeah, now after the class, I will share. Today morning, I have class. That's problem. I had class. Okay, sorry. I will send. Okay, kinetic chemistry. Okay, write down. First point. The area, the area, the area of studying about, the area of studying about rate of chemical reaction, rate of chemical reaction is called as the kinetic chemistry. It's called as the kinetic chemistry. It's called as the kinetic chemistry. Called as the kinetic chemistry. Next point. Some substance, some kind of substance within bracket reactants, within bracket reactants, within bracket reactants, some kind of substance within bracket reactants convert into different type of, convert into different types of substance, convert into different types of substance within bracket product, within bracket product by a chemical conversion, by a chemical conversion, by a chemical conversion is called as the chemical reaction, is called as the chemical reaction, is called as the chemical reaction. Okay, write down reactant by chemical conversion convert into product. Okay, reactants by a chemical conversion convert into product. Okay, that's the base. By a chemical conversion convert into product, that's the simple idea of chemical reaction. Simple thing, chemical reaction is that. Okay. Okay, now when we consider about any chemical reaction, take example. Take an example. We have test tube. Okay, we have test tube. Test tube, and we add some HCl, diluted HCl acid. Think example, diluted HCl acid. You know HCl is, we discussed. The HCl is an acid, powerful acid. In here we diluted that. Powerful HCl acid. And we think we add some magnesium part here. Magnesium part here. Magnesium part. Magnesium part. Then what happened? Magnesium and HCl reaction. I think you have done this practically in your O-level time. We add HCl and magnesium part. Then what happened? This magnesium and HCl reacting. What happened? Magnesium and HCl reacting. You know this simple HCl and magnesium, HCl and magnesium react each other, then it produces magnesium chloride, MgCl2 plus hydrogen gas. Hydrogen gas, it's a gas. Okay, that's a simple chemical reaction. Now tell me, what are the observation we can see? That's a chemical reaction, that's a chemical equation also. What are the observation we can see in this reaction? In the test tube, what are the observation? Yeah, send me. Yeah, good point. Yeah, air bubbling, yeah. What others? Air bubbling. Yeah, what other observations? Uh, yeah, no sound, sound. Yeah, sound also possible. Sound is not common. What others? Magnesium dissolving. Yeah, that's very important. Magnesium dissolving. That means the magnesium part is decay. Decay mean it is what? The decay mean it's disappearing. Disappearing. Uh, yeah, yeah, very good point. The surface, what happened? Amavi? The surface, what happened? Yeah, that's what happened to the surface? The surface, what happened? Yes, Alan, send me what happened. Yeah. If it, yeah, good. Hola, correct. Yeah, that's because that's a exothermic reaction. You know, acid and metal reaction. I told you last lesson. Therefore, exactly the surface is the surface is heating. Okay, they are the all observation. The surface should be heat and the reactant the inside temperature also increasing. One. The second one is the hydrogen gas. You can see the hydrogen gas. That means air bubbling release. Two observation. What others? Then magnesium chloride is a what? Is it acid base or mineral? That's a mineral like salt. The magnesium chloride. Sodium chloride is the our eating salt. No? The magnesium chloride also this type uh, mineral. Therefore, it's precipitate on the precipitate. Precipitate means deposit on the bottom. Deposit on the bottom. Three observation. What others? The magnesium part, what happened? The magnesium part decaying. That means disappearing, gradual disappearing. For observation. Yeah, if it is this HCl is not well diluted, the sound also possible. If it is well dilute means if we dissolve in water well, the dilution process will if it is dilute HCl, not common sound is coming. If it is power, the concentrated HCl, we can see some sound because this reaction speed is very high. Okay, then you can see when any reaction is happened in any container, whatever, when any reaction is uh, happening, that means reactant converting product, we can see some observations, no? We can see some color changes. Okay, what are the, in here no any color change, but there is different chemical reaction, the color is changing. We did in do you remember biorate test in biomolecule lesson? Biorate test, Benedict's test, Sudan retest, everything are chemical conversions. In everywhere the color was changed, remember, the color was changed, color was changed. Now we can see some evidences. There is a chemical reaction here. We can identify any chemical reaction by observations or evidences. They be called as evidences. We can identify evidence. Evidence we can identify there is a chemical reaction, and what are the observations we can decide according to this evidence. Okay, there are a lot of types of evidence. Okay, from this evidence, can we identify the rate of chemical reaction? Can we identify the rate of chemical reaction from these observations or evidence? Our target is calculate the rate of chemical reaction. From this evidence, why we discuss this evidence firstly in this lesson? Can we calculate, can we get the rate of chemical reaction from this evidence? Ashad? Yeah, a lot of evidence we discussed. Evidence mean observations. From this observation, can you get some idea about idea or value for rate of chemical reaction? This is our target of this lesson. Calculate the rate of chemical reaction. Can we get any idea or any? Yeah, we can get idea, but we can't get numerical value for rate of chemical reaction. We can't get value. Value mean this reaction rate is normally, rate mean capital R. Remember that we discussed later. The rate is 2.5 whatever unit. We can't get value, no? We can't get numerical value, but we can get some idea, some small idea we can get. Think we add that is diluted. Think this is diluted HCl acid and magnesium part we add. Think for this test tube we add some concentrated HCl acid and we add magnesium part. We add magnesium part. Then we can see in this thing, this is A and this is B. This is A and this is B. From A test tube, we can see the air bubbling and heating speed. Air normally mainly air bubbling speed. The air bubbling speed is very high and it is normal. Then we can get some, we can comparison and we can get some small idea about the rate of reaction. But the problem is we can't get the numerical value for rate of reaction. That's why that is our target of this lesson. Calculate we get the numerical value for rate of chemical reaction. Okay, in this observation, in this evidence, we can get idea, that some comparison we can get about the rate of reaction. Some general idea we can get, but the problem is from these evidences and observations we can't get a numerical value for rate of reaction, rate of chemical reaction. Our target of this lesson, calculate the rate of chemical reaction into numerical value. Okay, I think now you have some idea about the lesson. One by one we discussed. Okay, write down. When convert, write down new point. When convert any reactant into product by a chemical conversion, when convert any reactant into product by a chemical conversion, there are some observations. Some observations can be identified. Okay, write down observations, examples. Observation examples. What are the observations? First one, color variation. Color variation. Color variation. The second one is temperature change. Temperature change. Third one, temperature changes. Volume changes. Volume also can change. Volume changes. Air bubbling. Air bubbling. What are the precipitation? Form of precipitation. Form of precipitation. There is a structured question also came from this part. Therefore, careful. Form of precipitation. 6. What are the reactant decay? Decay. Okay, write down this example. Okay, the other observations we can identify there is a chemical reaction and there is or evidence we can identify there is a chemical reaction here we can identify from this observation. Okay, next point. After example, write down next point. From these evidences, can get a small idea about the rate of reaction. Can get a small idea about the rate of chemical reaction. Can get a small idea about the rate of chemical reaction. But impossible to get a numerical value, get a numerical value for the rate of chemical reaction. Get a numerical value for the rate of chemical reaction. Same point. The target of this lesson is obtain a numerical value for rate of reaction in any chemical reaction. The target of this lesson is obtain a numerical value for rate of reaction in any chemical reaction. Okay, that's our target. Okay, that's our target. What is the target? Calculate the rate of reaction into numerical value. That's our target. Okay, we'll see how we can get a numerical value. That's a very long journey. That's very, you have to very carefully understand the initial parts are theory. They are not much hard, but finally we discussed expression part. This expression part you have to follow very carefully, otherwise you will, if you miss any part, it is difficult. Okay, I after this today and after next day, third and fourth week of this lesson is very important. In this lesson, in these days, we discussed about this expression and calculation, same as last month. Therefore, follow continuously. Okay, now according to the rate of reaction, we can divide chemical reaction into three main types. Okay, this chemical reaction, we can divide into main three types. According to the rate. According to the rate means the commonly we have idea the speed of reaction. Okay, speed, common idea. The first type is slow reaction. The second part is normal speed reaction. Final part is high speed reaction. Okay, that's the thing. According to the rate of chemical reaction, the chemical reactions we divide into main three types: slow reactions, normal speed reaction, and high speed reaction. What are these What is the meaning of this slow reaction? Slow reaction means it takes several days or many several. That means long time it take for reactant convert into product. It can be several years. When reactant convert into product, it can get many years, like millions of years. It can get. They are the slow reaction. Of it take a few months, like this. They are very slow reaction. Give me what are the examples for slow reactions? Can you give slow reactions? Adish, what are the slow reactions? Yeah, what are, yeah, three answers. Rock degradation, very good. Uh, Sand, soil formation. No? Yeah, that means, yeah, rock degradation. Rock degradation is a physical or chemical process. Yeah, according to others' mind, that's rock degradation. Is it physical? It is chemical. Is it chemical? The rock degradation is a chemical. Chemical. No, no. Lot of answer. No, no. It is a chemical reaction because uh, some rocks are produced by some minerals, and that's a collection of lot of minerals. Yeah, that's a chemical reaction because it is produced by minerals and lot of that's a collection. Then with rainwater, this with rainwater, these minerals and other compound reacting several time. That means that it's not 1 or 2 day process. That's a very long time it take for convert rock into soil. After rock is degrade, that the soil is formed. That's the soil formation method actually. The rock degradation like reaction, they are very long time reactions. They are very slowly this reactant means minerals in the rock reactant, then product is soil. After degrade, the soil is producing, then that's a chemical reaction. Lot of chemical conversion is there. Yeah, corrosion of, yeah, corrosion of iron. I know whatever corrosion of metal. Corrosion. What happened in corrosion? What happened? What are the reactants in corrosion? That also takes several months or few. It can also say few years. Uh, what are the reactants in corrosion? Yeah, send me. They are very simple thing we discuss. They are very common general thing we discussing in this test. Yeah, metal, any metal and oxygen, that's a corrosion reaction. The product is ferrous oxide or whatever metal oxide is produced, that's the corrosion. That's the corrosion. Then others, then The formation of fossil fuel, that's also same. That's also a chemical process. That's not only a single step reaction, that they are very long reaction. Other thing is when this 2D convert into vinegar, otherwise vinegar production. Vinegar production, what are the reactants? Vinegar production, ethanol and using ethanol we produce vinegar. Vinegar produce ethanol and oxygen. Ethanol and oxygen react, then convert into acetic acid. Acetic acid, that's also chemical reaction. That also takes several time. It takes a few time. Carbon dioxide dissolve in liquid like soda. It can slower in time. Carbon dioxide dissolve in liquid. Yeah. No. In natural condition, dissolving is slow, but when soda production, we dissolving in high pressure and that artificial condition. That's not slow in this type. In this case, it's not slow, but in naturally, every gases dissolved in water and any liquid, that is slow. But in soda and other cold drink production, everything we dissolve carbon dioxide in water, artificial condition and high pressure condition. Therefore, it's not slow reaction in this case. Clear? The formation of coal. Yeah, the formation of coal. Yeah. Any previous somehow NAS? Yeah, send me decomposition of organic matters. Yeah, organic matters decomposition, that's very slow. They are biological process, but the thing is the chemical conversion, the microorganism help for that. That's the thing. We discussed these organic matter decomposition and humus production process in microorganism processes as well. Yeah, photosynthetics, very good. Photosynthetic. Photosynthetic reaction. It also very slow reaction, and same the formation of coal. Okay, that enough. Formation of coal. Okay. Normal speed reaction. What are the normal speed reaction? Normal speed reaction mean reactant convert into product within a few minutes or few hour. Within 1 hour time period, within few minutes, convert. What are the examples? Within few hours or within few minutes, within the normal speed. Think about name. They are slow reaction. Normal speed. It take comparatively it should speed. Dissolving salt in water. Salt dissolving water. It's not a chemical reaction. That's a physical process. What is a product is produced? Normally, think sodium chloride. We dissolve in water. Then after the sodium chloride solution, also sodium chloride and water. No any product is produced. Not any product is produced. That's a physical. That's it. No any chemical reaction. If anything, sodium chloride and if anything, what are the? Yeah, burning. Yeah, that's not a chemical reaction. Okay, in here, no any chemical conversion. That's why I told you. In chemical reaction should have a reactant as well as product, and chemical conversion should have. They are compulsory. I told you. What are the example for normal speed reaction? Fuel burning, and flower blooming, blooming. Fuel burning is high speed or normal speed. Fuel burning is high speed or normal speed. That is no. The high speed is fuel vapor burn. Remember, okay, in this lesson, in our syllabus, fuel burning is not the fuel. That means petrol, if we burn, that's a normal speed reaction. In our syllabus, fuel, that means diesel burning, that is normal speed reaction. In engine, what happened? In petrol engine by carburetor, they produce air fuel mixture. I think you have idea if you heard about some automobile knowledge. In carburetor, they produce air fuel mixture. This air fuel mixture burning is very efficient. It takes milliseconds. Within milliseconds, that is burning. That is a high speed reaction. And in Hiroshima, Nagasaki, when I list down what you remember. Hiroshima, Nagasaki. Hiroshima in Japan. Yeah, nucleic bomb. No? Nucleic bomb. Therefore, the nucleic reactions are very nucleic reactions. Nucleic reactions, they are very high speed reaction. Yeah, explosion reaction, very good. Explosion reaction. Explosion reaction mean like when we produce fire, that is explosion sound. They are Ratinya, that is explosion, that is high speed. What happened others? Atomic reactions. They all are very speed reaction, high speed reaction. They are and fruit ripening, that's a normal speed. That means it takes several hours only, few hours. Okay, I think that's enough. Okay, we write one more. Electrolysis. Electrolysis, I think you remember electrolysis reaction in O level. Electrolysis reaction also normal speed. Electrolysis. Okay, that enough. Okay, prepare this table. They are slow reaction, slow speed reaction, normal speed reaction, and high speed reaction. Divide into 3 sections and write down examples. If you want, you can find another in our syllabus. This type few examples mentioned here. Remember this: the fuel burning is not high speed reaction. That's important. Fuel burning is not high speed reaction. That's a normal speed reaction. Fuel vapor burning is the high speed reaction in syllabus. Okay. Okay, divide the table into 3 groups and write down. Okay, I think finish. Okay, finish. Send me message. Okay, now actually we are going to start the lesson. Okay. Okay, write down topic. Chemical reaction in molecule. Oh no. Quickly. Okay. Write down topic. chemical reaction in molecular level. Chemical reaction in molecular level. That's the key. Very important point. In your lesson. Okay, very important part. Chemical reaction in molecular level. Chemical reaction in molecular level. Chemical reaction in molecular level. In molecular level. Okay, now carefully understand this part. If you not understood this part, other we discuss factors part will break. Okay, therefore try to get maximum idea in this part. Okay, in this reaction. Okay, first I explain you the chemical reaction mean reactants convert into product. Okay, we'll take example, our previous example again. When we consider about magnesium and HCl reaction. Okay, we'll take sodium chloride reaction. Sodium and HCl. Then what are the product? Sodium chloride is produced. Sodium chloride, you know. The sodium chloride characteristic, you know. Sodium chloride means we eating salt, and hydrogen gas is produced. Hydrogen gas, H2 gas is produced. Okay, now see, you know sodium characteristic, you know sodium is a solid. Okay, sodium is a solid. You know sodium characteristic. Solid mean S means solid. Okay, we have four physical states of matters in these chemistry lessons. We have four physical states. That means S means solid. I will explain again this part. Solids. The L mean liquids. The G means gas, capital G. Sorry, simple G. Gas. What is the meaning of our final one? AQ. All are simple. AQ. Aqueous. This HCl is a aqueous solution. HCl is a aqueous solution. What's the meaning of aqueous? Aqueous. Ashar, what is the meaning of aqueous? AQ. Yeah, water added, not full water added. No, Ashar, liquid solution mean L, no? Liquid mean L. Aqueous, I asked. AQ. Simple A, simple Q. Yeah, very good. Very good. Aqueous mean, remember, aqueous mean dissolved in water. Yes, very good. Aqueous mean dissolved in water. Not sodium chloride, HCl dissolved in water. HCl aqueous solution mean hydrochloric acid dissolved in water. The solid mean, solid mean powder or solid part. The sodium chloride also produce. Sodium chloride is salt. That is a mineral. Yeah. The sodium chloride produce sodium chloride is salt, because very dust powder is produced. Then that is gas. That is gas. Okay. You can see that not I want to explain, but I think you get some idea about physical status of any reactant or products. Now, okay, Asha, the aqueous not equal to liquid, okay? Aqueous not equal to liquid. Aqueous mean, Asha, see that if we consider about water, H2O, that pure water, H2O pure water, is it aqueous or liquid? Pure water, aqueous or liquid? Pure water, aqueous or liquid? Alan? Pure water, aqueous or liquid? Alan? Amma, what you think? Pure water? Yeah, liquid. Good. Yeah, I think I gave message something delay. Yeah, that's a liquid. If anything think they'll say HCl, that's a water. If we add some HCl here, that's a pure water. Okay, pure water. Okay, then we add some HCl. Then it's become HCl solution, HCl water solution. That's the called as aqueous. That we called as aqueous. That's aqueous. Okay, think we have pure HCl. Pure this HCl, that is aqueous or liquid. Is pure HCl, pure HCl, concentrated 100% HCl, liquid. Very good. That is liquid. If we dissolve, if we dilute and produce a solution, that's the aqueous. Arshad, clear? Arshad? Arshad? Here? Okay, good. Okay, not that note I want to explain. You can see, sodium characteristic. I think the sodium you have seen, the HCl is a solution, You can see the sodium chloride is produced, no? Sodium chloride and hydrogen gas. When we consider about characteristic of, in this reaction, they are the reactants. Sodium and HCl are the reactants. They are the reactants. They are the product. They are the product. They are the product. They are reactants. Now you can see, think about characteristic of reactants and product. What you can think, what you can say. Sodium and HCl characteristic, can you see it is totally changing when converting to sodium product, sodium chloride? That is totally changed. The characteristics are totally conversion, no? That's after chemical conversion, the produced products are totally different. There's no any some kind of equal characteristic. Okay, but when the commonly generally the all characteristics are totally changed. The sodium chloride is a another form. No any gas here, but there is a gas is produced. Now we are going to discuss in molecular level how this conversion, the characteristics are how change in that much level, how characteristics are changing. Okay, I told you every matters when we consider about solids, liquids, and HCl is hydrochloric acid known as yeah, HCl mean hydrochloric. Yeah. Hydrochloric acid. H2SO4 means sulfuric. Yeah. What I told you, the characteristic what happened, they are totally changing. You know, the with chemical conversion, reactor converting product, their characteristics are as looking, they are totally changing. What is the reason here? I told you every matters means solid, liquid, and gases, all are produced by molecules. Now think, they are the sodium molecules. Example, okay, they are the sodium molecules. They are sodium molecule. They are sodium molecule, and think they are the HCl molecule. HCl molecule. Don't think about shape, okay? There I take only explain. They are not like this. Okay? Think they are HCl molecule. They are sodium molecule. They are HCl molecule. Then when we add these two reactants together, think that's a beaker or whatever test tube or beaker. We add some HCl and sodium part in here like this. Think that is a sodium part. Then what happened? These two molecules collide each other. HCl molecule and sodium molecule collide each other. Don't think about shape, okay? They are not in this shape. I could only understand. Okay. Then what happened? Think they are the two molecules. That's a sodium molecule. That's a HCl molecule. These two molecules collide each other. Okay. These two molecules collide each other. Now you can see this sodium. Sodium is a solid. Solid mean I think you remember. Solid mean they have very strong bond between molecule. Very strong bond. Very strong bond. Think the HCl mean aqueous, but the structure is same as liquid. If it is aqueous, it is the molecular structure is same as liquid. Now they have some normal type bonds, intermolecule bond, normal type. The sodium bonds are very strong. Now what happened? These two molecules collide each other. What happened? They are already available bonds. Already available bond means in this molecule there is bond like this. There is bond, existing bond. Existing bond mean that's a solid. That's a sodium is a solid. They have bonds. This bond, what happened? Already available bonds. Already available existing bond breakdown. Carefully understand. Already available existing bond. That means this bond, this intermolecule bond of solid, they what happen? Break down, and when collide each other, they produce new bond between these two molecules. They produce new bond when collision. Produce new bond. Okay, I again explain. Now what happens? So this, that's the one reactant, sodium reactant, sodium molecules. This solid that produced by molecule. That's HCl, another reactant that also produced by molecules. Then what happen when we add HCl and sodium? That means two reactants when we add together. What happened? They are molecules start to collide each other. Molecules start to collide each other. Therefore, they are already available bonds. What happen? Break down. They are already available bonds. That these bonds break down and produce new bonds. Produce new bond between them. In here, there is a new bond is formed. Then that's the sodium chloride. That's the product. That's the product. That's new bond formed. After new bond formed, this structure is the sodium chloride and hydrogen gas. That means product is produced by already available bond breakdown and convert and for producing a new bonds. Clear? If not, ask. I explain again. Others? Yeah. Explain again. Yeah, I explain. Others? Yeah. Ashat? Yeah, be sure to clear. I also mean. I explain. Okay. Okay. Okay, I told you earlier, every types of matters are produced by molecule. That means solid, liquid, gases, everything. That's the three types. No, they are all are produced by everything in the world produced by molecule. They are building materials are molecule. Okay, think now sodium in this example. Now I told you the physical status if the reactant should be solid, liquid or gas or aqueous. Then aqueous also their molecule structure same as liquid structure. Therefore, if there are any reactant should be solid, liquid or gas, the molecular structure. Therefore, every reactants are produced by molecules. Every reactants are produced by molecule. I told you they have intermolecule bonds between each molecule in solid reactant, solid, gas, and liquid. Everything intermolecule bonds. They are strong is depend on their state. The strongest of these their intermolecule bond depend on their state. The solid very strong, and that's another story. Then you need to understand every reactants are produced by molecule. Their building blocks are molecule. Okay, every reactants. Okay, now think sodium. That's example I got. Not only that, every reactants are produced by molecules. Now, sodium is a solid, HCl is a aqueous or liquid. Then all are produced by molecule. Then all have intermolecule bond. Intermolecule bond mean they have all their own bonds. on intermolecular bond, the bond between each molecule. එයාලට bond තියෙනවා. හරි. Now, when we add these two reactants, normally in any reaction, we have to add this. We have to mix these two reactions. In industry chemistry, we'll see lot of huge reaction we discussed in industry chemistry. But now these two reactants, when we adding, what happened? Their molecules collide each other, start to collide each other. Think practical thing. Think we add sodium powder to better understand. Sodium powder means we add sodium powder like this. Then molecules are spread. Molecules are spread. Then they are sodium molecule. Think for better understand. They are sodium molecule. Then out this beaker, HCl molecule. There are a lot of HCl molecule. When this mixing, what happened? Each sodium and HCl molecule, they are HCl molecule. They are HCl molecule. Think they are HCl molecule and the bold one are sodium molecule. Okay. Now what happened when we mixing means when we add together, they are mixing. When mixing, they are each reactant molecule collide each other. Okay, when collision, they are already available. That means this already available bond break down and produce new bond. Okay, they bond break down, this bond break down and convert into here new bond. After this new bond form, that's called as a product. Okay, that's how their characteristics are changing. That you want to understand. You can see sodium characteristics are not equal to sodium chloride. HCl characteristics are not equal to sodium chloride. The both together and produce new bond is it has different characteristics than them. That's why the sodium chloride is that its characteristics are changing totally with other reactors. Now, okay. And then yeah, if you have normal idea, that enough. Again and again we discussed, you can get full idea. Okay, in next part you can get full idea. Okay, now enough. Yeah. Okay, now. Okay, no problem. Okay, now, okay, what happened? They are already available bond breakdown and when collision, they are already available bond breakdown or and produce new bonds. Okay, that's the thing you want to understand. When they produce new bonds and break down already available bonds, they should complete three main requirements. This three requirement always asking every question, every exam paper, anywhere, CQ question, no structure, no essay paper, anywhere that is asking. Three main requirements should fulfill. If it is after these two molecules collide each other, they are already available bond break down and produce new bonds. They should complete three main requirements. Okay, the first one is okay, where I write? I'll erase this. The first one is first requirement is requirements. This topic also I erase, no? Okay, what I now explain. Now I think the story is clear. Now what happened? Only that you want to understand. Sodium and chloride, sodium, every reactants are produced by molecule. When we mix these two reactant into one, okay, they are molecules start to collide. When collision, they are already available bond breakdown and convert into new bonds. They are the product. That enough. Okay, they are already available bond breakdown and convert into product. Now, when these two reactant molecule collide each other, they are bond breakdown and convert into new bonds. For this process, three main requirements should fulfill. Okay, three main requirements should fulfill. The first one is requirements. Three main requirements should fulfill. First one is collide each other. Reactant molecule collide each other. That means basically, if it is bond breakdown and already available bond breakdown and produce new bond for this process, the reactant molecule first requirement is reactant molecule should collide. Okay, that is first requirement. The second one means collide with proper orientation. Proper orientation. What is the meaning of that? Proper orientation mean? Your idea? Yeah, first one is simple. I told you reactant molecule should collide. Proper orientation mean? Same words in proper orientation. That's a word available in syllabus, but it is complex. Yeah, according to your knowledge, send me a same word for orientation. Proper orientation. Proper orientation. No idea? Collide with proper orientation. Correctly aligned. Yeah, something correct. Others? Proper orientation. I ask simple meaning for proper orientation. Correctly aligned. Yeah. Logically structured. Logically structured mean no, it's not. Yeah, correctly aligned is something correct. The proper orientation mean like this. Proper orientation mean these two reactant molecule should collide with proper orientation like this. Okay, think these two molecules are react like this. I shaded that for separately identify these two molecules. Okay, think these two molecules collide like this. That means improper orientation. Orientation means actually this direction. It should be proper direction to break down bond. Okay, if it is collide like this, think this is the two molecule. This is the two molecule. They are collide with here like this. Then it is proper orientation because in this collision the bonds can break down and they can produce new bond. Think these two molecule collide like this. Collide like this. Then is it enough? This collision is enough for breakdown bond and new bond formation? Yeah, not enough. Therefore, is it not worth? If it the two molecules should be collide with proper orientation like this, not like this. Understood? That means proper direction. If you not understood orientation. The second point is understood. Okay, third one. Okay, what is first one? To break down bond, to break down already available bond, these reactant molecules should collide each other. This second one collide with proper orientation. The third one is collide molecule exceed the activation energy. Exceed the activation energy. Exceed the activation energy. That is that I explain after writing this, otherwise you will complex, no? Okay, start to write. Okay, where we stop? The chemical reaction in molecular level, no? The chemical reaction in molecular level. Okay, write down first point. Chemical reaction in molecular level, write down first point. After that, I will explain what is the meaning of this third and this story I will explain after we complete this part. Otherwise, you will complex. Okay, write down. Write down. Every reactant molecules in any chemical reaction, every reactant molecules in any chemical reaction, every reactant molecules in any chemical reactions, in any chemical reaction are produced by molecules, are produced by molecules. Are produced by molecules. Are produced by molecules. Are produced by molecules. when mix two or three, when mix two or more reactant molecule together, when mix two or more reactants, not reactant molecule, when mix two or more reactants together, when mix two or more reactants together, their reactant molecules, their reactant molecules, their reactant molecules start to collide each other, start to collide each other, start to collide each other. And normally we finish 9 p.m. Okay, 9:15 probably. Yeah, where we stop? Uh, yeah, I forgot. When two or more reactants mix, when two or more reactants mix, their reactant molecule collide each other. Their reactant molecule collide each other and reactant molecule collide each other and they are already available, they are already available, existing bonds are breakdown. Already available, existing bonds are breakdown. Already available, existing bonds are breakdown and produce new bond between reactant molecules. Produce new bonds between reactant molecules. Produce new bonds between reactant molecules. Next point, therefore, the characteristic of reactants, the characteristic of reactants, the characteristic of reactants are totally changing with, are totally changing when produce product, when produce product after chemical conversion, when produce product after chemical conversion, after chemical conversion. Okay, that's the thing. Okay, example, uh, write down this example and reactant and product and draw this structure for better you understand. According to your understand, you can write down steps and mention this requirement. I will give you later. Okay, write down this. Draw that. Finish? A simple thing. We mix together. Then already available existing bond break down and write down, produce new bond between reactant molecules. Then they are the product. Okay, good. I think you have full idea about this story. That's like a story. Two molecules combine, collide each other, then their existing bond break down, and between these two molecules produce new bond. That's a new bond. Therefore, that's the reactant characteristic, not product. Product produce new characteristic because of this new bond. Alan, finish. Good. Okay. Okay. Write down. Next point. Next point. When collide reactant molecule each other, when collide reactant molecule each other, if they convert into product, if they convert into product, the reactant molecule, if they convert into product, the reactant molecule should fulfill three main requirements. Should fulfill three main requirements. Should fulfill three main requirements. Write down first one. Reactant molecule collide each other. Reactant molecule collide each other. Reactant molecule collide each other. Second one, reactant molecule collide with proper orientation. Reactant molecule collide each other. Reactant molecule collide with proper orientation. Third one, collide molecule sorry, give me a second. Yeah, final one. Collide reactant molecule exceed the activation energy. Collide reactant molecule exceed the activation energy. Collide reactant molecule exceed the activation energy. Exceed the activation energy. Collide reactant molecule exceed the activation energy. Okay, now write down the topic activation energy. Subtopic activation energy. What is the meaning of this activation energy? Activation energy. Activation energy. I think all level time you have heard this word, activation energy. Activation energy. Think activation energy means every reaction there is a minimum energy level. They should this energy level should complete this reactant molecule convert into product. Think that's very important point. That point very important for understand our future things. Then think we have A, B, C reactant molecule. Okay, I simply explaining very clearly understand. We have A, B, C. They are reactant molecule. This every reactant molecule has an energy level. Like us, our when we consider about 3 students, they have different energy levels. Same as these 3 reactant molecule, they have own energy level. As example, you see this A molecule has 2 joules. A molecule 2 joules. They have A molecule energy own energy level is 2. 2 joules they have. The energy mean joule. Then think the B is 3 joules. That is more energy than A. 3 is 4 joules. Okay. There are 3 reactant molecule. Every reactant molecule have their energy level. Okay, that depend on the reactant molecule. Okay, they have energy level like us. We have also energy level. The reactant molecule also they have energy level. Now, this A, B, C reactant molecule that is 2 joule, that is 3 joule, that is 4 joule. The activation energy means the minimum energy of reactant to convert into product. Okay, to participate in the reaction. The minimum energy of reactants to participate the reaction. This activation energy is the activation energy is think 3 joule. That means the minimum energy of any reactants, the minimum energy of reactant should participate in the reaction. To participate in the reaction. Okay, this activation energy for this reaction, as example, it is 3 joule. Now, this A molecule collide. Okay, A molecule collide. A molecule collide. And A molecule collide with proper orientation. Okay, no problem. A molecule collide with proper orientation. But their energy level is 2 joule. Is it possible to convert in product? A. A molecule. Is it possible to convert into product? This A reactant molecule think collide with other molecule. Then is it possible to convert into product? The activation energy is 3. Activation energy is what? The minimum energy level of reactant to participate in the reaction. Okay, but the A energy level is 2 joule. That not fulfill the minimum energy requirement. Therefore, the A molecule cannot participate in the reaction. If they collide, A molecule can't. Think B molecule. B molecule, they have energy 3 joules, therefore no problem. If they collide with proper orientation, no problem, they can convert into product. C molecule, no any problem. If they collide, convert into product, then what is the meaning of activation energy? What is the meaning of activation energy? The activation energy means the minimum energy of reactants, the minimum energy level of reactants to participate to the reaction. Okay, that's the activation energy. Write down. Clear first? That's very important to understand this part. I think, do I need to explain again? Allah, need to explain again? Okay, I explain it. No, I explain again after I. Okay, write down. The activation energy is a subtopic. The activation energy, the minimum energy of reactants. In this definition is always asking. Therefore, the minimum energy of reactants. These three words should there. Otherwise, if you write anything, you wrong. The minimum energy of reactants. The minimum energy of reactant molecules. The minimum energy of reactant molecules to participate to the reaction. To participate to the reaction called as the activation energy.
Sir, can you repeat?
Yeah, the minimum energy level of reactant molecules the minimum energy level of reactant molecules to participate to the reaction called as the activation energy. Called as the activation energy. Next point, if reactant molecule don't have own energy level exceed the activation energy, they can't participate for the reaction. They can't participate for the reaction. They can't participate for the reaction if they collide with proper orientation. If they collide with proper orientation, they can't participate for the reaction if they collide with proper orientation. Now I think you have idea. Now tell me what are the requirements? What are the requirements? Reactant molecule collide each other. That's the first requirement. It should collide. The second one is collide each other with proper orientation. Collide each other with proper orientation reactant molecule. The third one is collide reactant molecule exceed the activation energy. That means the minimum energy of this reaction. That this activation energy not same value, not 3 joule. That's example. Okay, that depends on the reaction. The reaction to reaction, the activation energy is changing. That depends on the reaction characteristic. Okay, we discussed later how activation energy changing, everything we discussed. Now, today we discuss basic things. Today we discuss basic. Today you want to understand the activation energy of reaction depend on their characteristic. Okay, the reactant molecule if exceed the activation energy only, they can participate to the reaction. That means this. Now tell me one question. This A molecule 2 joule or their own energy level is 2 joule. Think this is the A molecule. This is the think the blue one is the A molecule. That is B molecule. Then these two molecules collide each other. Okay. Then what happened to this A molecule? What happened to this A molecule? Is they convert into product or not? Is it convert into product or not? Is it convert into product or not? Send me, otherwise you will trouble. Better understand this part, very important. No, this is not converted into product. Then what happened to that? In the reaction, what happened to this molecule? That's my problem. It don't have energy level than exceed the activation energy. Therefore, it cannot convert into product. What happened to this reactant molecule? What happened to this A reactant molecule? That's my problem. Yeah, think. What happened to this reactant molecule? What happened to this reactant molecule? Ashad, what do you think? What will happen? Think here, they are sodium. They are sodium molecule. They are HCl molecule. Then these two HCl and sodium molecule collide each other. Then it's not fulfill one or two requirement. Minimum, at least one requirement not fulfilled, they cannot convert into this product. Then what happened to the sodium HCl? Then yeah, very good. Yeah, two answers very good. Remain unchanged and continue exist in their original form. Yeah, within the reactant. Very good, very good. They are remain as reactant, not convert into product. You know, if we add sodium part into HCl, not every HCl finish. Yeah, in thermal chemistry, in heat of reaction, you did. We did excess amount mean only the number of moles of sodium is finished. After this finish, the reaction is stopping because sodium is completed. Therefore, the other HCl is remain. Other HCl molecules are remain, not reaction. What first answer? Effect. Yeah, very good. Yeah, that's the thing. They not reacting and remain as reactant, not convert into product. Okay. Okay. They are not converting product. Okay, then I told you they are the requirement should fulfill uh, any reactant molecule after collide. If they break down and produce new bond, these all requirements should fulfill. Therefore, if any molecule exceed, if any molecule complete this all requirement, there is a special name that we call as effective collisions. Effective collision. Remember, okay, if any reactant molecule complete this all requirement, okay, if any reactant molecule complete this all requirement, that we called as This collision we call as effective collisions. Effective collision. Effective collision. Then only this effective collision is happen any molecule, only that convert in product. If not complete this all requirement, if at least one requirement not fulfilled, it cannot convert into product. Okay, it cannot participate into reaction. Okay, I think the story now clear. Very simple and very the continuity story. That's if you understood every story, it is simple. Okay, write down new point. Not new point. Write down is star mark. Star mark. Collisions of reactant molecule. Collisions of reactant molecule complete all above requirement. Collisions of reactant molecule complete all above requirement. Collisions of reactant molecule complete all above requirement. Complete all above requirement called as effective collisions. Effective collisions. Effective collisions. Effective collision. Effective collision. If not at least one character, if not at least one requirement fulfilled, if not at least one character, if not at least one requirement fulfilled, if not at least one requirement fulfilled, this collision molecules not participate to the reaction or not participate to the reaction or not convert into product. Not participate to the reaction or not convert into products. Okay. Not convert into products. Okay, other important message is in last day revision. Sunday revision, we did some advanced calculation of heat lesson we discussed. If you not if you not participate, watch this video. That is very important. Some we not that much this advanced calculation we not did in our theory class. We did actually model paper question we discussed. That is very good questions. We did. If you not participate, watch again. If you participate also, try it again. Do these questions alone. Try again. Then you can get more knowledge. Okay. I think now very clear this story. What happened is reactant molecule collide each other. They are already available on breakdown. and newborn formation, they are the product. If they collide, in this collision, if they break down and newborn form, they should complete this requirement, collide with proper orientation and collide molecule exceed the activation end. That means minimum energy level they should have. Okay, the minimum energy level they should have. Then if they complete all these requirements, that we call as effective collision. This effective collision, if any molecule only effective collision is happen, if this collide with effective collision only, they can convert into product. Otherwise they cannot convert into product. They can't participate in the reaction. That's the full story behind the reaction molecule in molecular level. Clear? Very tight. Okay, all send me this part, we can finish if you all clear. Send me, is it clear or not? Okay, Alan, send me message after class. Okay. Uh, Write down the topic, rate of chemical reaction. Rate of chemical reaction. Rate of chemical reaction, 90. Rate of chemical reaction. Rate of chemical reaction. Rate of chemical reaction. Okay, what is the meaning of this rate of chemical reaction? Yeah, in generally it is the speed. What is the meaning of 9:15? We finish today. Why asking? Class is finished. Yeah, now 9:15. Okay, 9:15 normal time. Okay. Now today we have very small part. Okay. What is the meaning of rate? Normally, do you know the rate of velocity change? What is that? That is acceleration. To understand that, the rate of velocity change, the acceleration means the delta v, I think they are O level, divided by d. That is the rate of velocity change, that is acceleration. Then tell me what is the rate of chemical reaction. Rate of chemical reaction. Now, think when we consider about any reaction, the reactant, what happened? Reactant convert into product. Then tell me what happened to reactant concentration? Reactant concentration increase or decrease? Reactant concentration, the concentration of reactant increasing or decreasing? The reactant concentration, simple thing. In this example, sodium plus HCl example, the sodium and HCl increasing or decreasing? Think. Sodium, any reactant concentration increasing or decreasing? Normally reactants are decaying. That means gradually what happened? Reducing, and product gradually increasing. Isn't it? The reactant concentration gradually decreasing. Initially, the reactant concentration is maximum. The product concentration is, think, initial reactant concentration is 100. Product concentration is 0 because no any product. Now what happened with time? With time, that is gradually decreasing and it is gradually increasing. The product concentration gradually increasing. Is it okay? Understood? Not. Reactant concentration gradually decreasing. The product concentration gradually increasing. Okay, therefore, we call the reactants are the reactants are decaying. But are confusing me? Think reactor. Think initially reactant. What happened? Understand this example. Sodium plus HCl. Our previous example. Sodium chloride. Then hydrogen gas. Then initially the sodium in this container, think practically we doing reaction. First sodium, think initially sodium and HCl, only sodium and HCl, no any sodium chloride and hydrogen. Okay, when we start, after start the reaction, what happened? The sodium concentration and HCl concentration gradually decreasing, and sodium chloride and hydrogen concentration gradually increasing. Now, okay, think it practically when in practical reaction is happening. Alan? Yeah, let's see. Now you can see the concentration, the reactant concentration gradually decreasing and product concentration gradually increasing. Okay, decreasing and increasing, decreasing and increasing. Okay, now you can see the concentration always changing. The reactant concentration decreasing, product concentration increasing. Okay, then we can write the rate of chemical reaction. Always rate mean what? Always rate mean within unit time. Okay, the rate of acceleration, rate of velocity change, that is acceleration. The rate of displacement change, that is velocity. Same. Then the rate of reaction mean, the rate of reaction, that means capital R, rate. The rate of reaction equal the concentration change. The concentration change over time. That's the meaning of rate of chemical reaction. The concentration change of reactant or product within unit time. Okay, the concentration change of reactant or product within unit time, that is the rate of chemical reaction. Okay, in this calculation part, final part, we discussed again and again this with expressions. Now that enough. That's the basic concept is enough. Now write down. The topic is rate of chemical reaction. Today I just want to give you the basic of this lesson. Then next day we can easily start our second part. Then third part we go to calculation part. Final day we discuss questions, same as last month lesson. Write down. Reactant or product. Reactant or product. Concentration change. Concentration change within unit period of time. Within unit period of time is called as the rate of chemical reaction. Rate of chemical reaction. Write down. Rate of chemical reaction, capital R, equal to rate of chemical reaction, capital R, equal to the concentration change of reactant or product. The concentration change of reactant or product divided by time. Divided by time. Okay, this part the divided by time. Finish. This part we discussed in calculation part, how this reactant concentration, how change, product concentration, how change, what are the differences, everything, how we develop expression for reactant and product decaying rate and producing rate, and how these get relationship them decaying or producing rate, how we get relationship between with rate of chemical reaction. Okay, everything calculation part. Okay, now write down topic factors affected to the rate of chemical reactions. Factors affected to the rate of chemical reaction. Factors affected to the rate of chemical reaction. Factors affected to the rate of chemical reaction. these factors we can divide into two main types. Okay, these factors we can divide into two main types. The first one is main factors. Main factors. Main factors. The second one is indirect factors. Main factors or direct factors. Main factors or direct factors and indirect factors. Okay, under main factors affected to the rate of reaction, very important is the first one is temperature. Temperature. Next one, reactant concentration. Remember, not product, reactant concentration. Reactant concentration. The third one is catalyst. Catalyst. Fourth one is physical state of reaction. Reactants. Physical states of reactants. Indirect factors affected to the rate of reaction. The pressure, the light condition, then UV radiation, and fourth one, what others? pH value, electric current, okay, they are the factors. Okay, they are the factors. They are the factors. That mean they are the factors affected to the rate of chemical reaction. These factors we can divide into main factors and direct factors and indirect factors. Okay, these direct factors are temperature. That's an exam question. Both factors asked in the exam. The direct factors are temperature, reactant concentration, catalyst, and physical state of reactants. In this lesson, remember, we further discussed only these direct factors. In our syllabus, indirect factors, we not discussed further, but you have to remember, not only these factors affected to the rate of reaction, other than these factors, there are other indirect factors also there, but we not only discuss in this lesson, but they are affecting. Okay, they are affecting, but not directly. They are indirect factors. They are the direct factors. One by one, next week we discuss about these factors. Okay, write down. Factors affected to the rate of chemical reaction. Factors affected to the rate of chemical reaction. Factors affected to the rate of chemical reaction.
എല്ലാം ബാഗ് പോയി
Factors affected to the rate of chemical reaction can divide into main and indirect factors as follows. Main and indirect factors as follows. Then draw this chart. Main factors and indirect factors. Main or direct factors. Okay. Quickly draw this table or chart. 9:18, no? Okay, we'll finish. If you finish, send me message. Okay, finished now? Write down. If, sorry, in our syllabus, we only discuss further about direct factors as given in above. Direct factors as given in above. Direct factors as given in above. Write down the first topic, temperature. Temperature affect to the rate of chemical reaction. Write down first topic, temperature affect to the rate of chemical reaction. Okay, our next day task is complete these all factors affect to the rate of chemical reaction. These indirect factors we are not going to discuss one by one. They not in our syllabus. Okay, next day our target temperature, reactant concentration, catalyst and physical state, how affect to the rate of reaction and how these factors change when change, how what happened to chemical reaction and how in molecular level what happened to the chemical reaction when change these factors. Okay, therefore what you want to this week task, this molecular level part you have to clearly understand. If you have any problem, send me, ask me in WhatsApp, I will explain. this molecular part you want to somehow you want to clear. Yeah, I know it is something confused. It can be confused because this is first time it can be confused. Okay, no problem. But before next week you are because when we discuss about temperature affect to the rate of chemical reaction in molecular level, we have to discuss every factor we discuss in molecular level. Therefore, for that, the basic molecular level rate of the basic thing of molecular level, how to chemical reaction is happening, how reactant convert in product, that important. From this base, I explain these factor affectors. This factors effect I explain from this base. Therefore, this week before next day, again clarify, again refresh how this molecular level the reaction is converting to product, reactant converting to product. Okay, that's all for today. Next. Okay, I will send you. And we'll meet Sunday morning this week. I hope to complete thermal chemistry past paper questions, and we'll discuss another heat lesson calculation. We not do much. We not did more calculations in heat lesson. We'll do and area volume, other past paper questions we have to finish quickly, the area volume. Then area volume past paper questions finished. I think now we did 2015, 16, 17, 18, not 17 area and volume essay questions we discussed now. Okay, we'll try to complete these questions quickly. Then biomolecule, every questions we discussed, past paper questions, model paper questions, all we discussed in biomolecule lesson. But next heat lesson, every exam paper, we last day we discussed model paper question in heat lesson. That is very important, very good question. And next week I hope to thermal chemistry and heat lesson, past paper and model paper questions discussion. Okay, we'll meet next Sunday morning. Good night.